So this is the second video, and in this video we are going to stick with the idea that we're just looking for that general solution, but I'm just going to show you how to deal with the constant in a slightly different way, which is particularly useful when you get to that step 3, that manipulate step, to help you make your answers y equals. So what we're going to do to start with is we have our question over here on the right hand side. We're going to follow our process of separate, integrate, okay? So what I would like to do is I would like to get all of the y terms, that's that one and that one, together on the left hand side, and then everything else together on the right hand side. So I'm actually going to have to make that 1 over tan y dy, and then I'm going to make that x over 1 plus x squared dx. Now, unhelpfully, I've not left myself very much space, but I am going to have to put my integration symbol at the front of both of those. So I have essentially taken this bit here and divided it over onto the right hand side, and then I've taken up this dx up onto the right hand side as well as taking the tan y over to the left. Okay, so I'm pretty happy that I've done my separate. I now need to think about how on earth I'm going to integrate that. Okay, so this is where it gets a bit more tricky with these questions. 1 over tan y, the reciprocal of tan y, I can write as cot y. Okay, and then I'm just going to keep the right hand side as it is. You've got to be very careful that you don't choose to integrate one side but not the other. So if you're integrating the left, you have to integrate the right at the same point. So because I didn't want to do anything on the right hand side, I just had to write it out as it was before. Okay, now cot y, the integral of cot y, if we're looking at the left, the integral of cot is a standard integral that's in your formula booklet. So cot y integrates to ln sine y. So that becomes ln, we've got modulus as we always do when we integrate with a ln or an ln. So that's the left hand side done. The right hand side we have to think about a little bit more carefully. And you might be looking at that thinking, oh, maybe I have to use partial fractions. Maybe can I split the fraction up, which you can't do because the addition's on the bottom and not the top. And possibly you will spot that the top, x, is, give or take a constant, the differential of the bottom. Because if we differentiate the bottom, if we differentiate 1 plus x squared, we get 2x. And we have x on the top. So this is an example of when we're using that standard rule we learned, where you've got the differentiated expression on the top, whoops, and then you've got the function on the bottom. These were our reverse of the chain rule ones. And we found out that essentially it's ln of the bottom plus your c, of course. Okay, now we have got that constant in there, so that's so if it were 2x on the top, it would be ln of the bottom. Because we've only got 1x, it's going to be half ln of the bottom. Okay, so there you go. Then we have to put our constant. So what we've been doing so far is we've been putting plus c. Now, where you have both terms are currently written as natural logarithms, they're written as ln something, it makes sense to write your constant also in terms of a natural logarithm. So I'm going to put plus ln k. Now you can use any letter, but we tend to use k there. Now I'm happy that that's still a constant, because if k is a number, then the logarithm of k is also some constant, some unknown number. Okay, Now what that allows me to do is when I get to that step 3, remember step 1 was separate and step 2 was integrate, step 3 was manipulate, it allows me to manipulate this expression to make it as close to y equals. We're not going to get all the way to y equals in this one, and it just makes the whole thing a little bit neater. Because over on this left hand side, if I want to make this sine y equals, I need to get rid of that log, which I will do by taking the exponential of both sides. Left hand side is nice and straightforward. If I take the exponential of the left hand side, I'm just going to end up with sine y. However, on the right hand side, it's much easier to make that a single logarithm before you take the exponential of it, rather than having a couple of different terms. So what I'm going to do is I'm going to use my log rules, which mean that half is going to become an indice. So it's going to go up there. Okay, it's one of your log rules. Then the other log rule is that when you've got two logs added together, you can make that log of the two things multiplied together. So I can make that, let's put my modulus symbols in. Oh, that's wonky. That's supposed to read ln modulus k times 1 plus x squared to the power of a half. Okay, and that's what's equal to ln sine y. Now when I take the exponential of both sides, essentially I'm getting rid of the logarithm. So it becomes sine y equals k times 1 plus x squared to the power of a half. Okay, and k is that constant that we had earlier on. And that is a much neater way of dealing with that constant of integration. I am going to leave it like this. I could make it y equals by putting an arc sign on the right hand side, but if the question doesn't say explicitly that I have to make it y equals, I think it's actually neater to leave it as sine y equals. So that's your answer for that one. Okay. So just as a little bit of a summary in terms of those constant of integrations, for a normal expression, the ones that we did in the first video, just put your integration constant as just plus c. It can actually be any letter, and remember you only need to put that over on one side. Where you've got everything, the left hand side and the right hand side, like you do here, where you've got both those terms in terms of a natural log, it makes sense, instead of putting plus c, to instead do this and put plus ln k. Now that also works if you've got maybe e's as well. So maybe you've got exponential and then you've got some function of y. And then on the right hand side, maybe you've got an exponential and you've got some different function of x. Okay. And again, you could put plus c here, but it makes sense to put e to the power of c. And that will then just allow us to make things a little bit easier. Okay. It's not wrong for you to put plus c. You will end up with the same answer at the very end if it's a particular solution you're finding. But often you are asked to put your answer in a certain format, and to do that you need to put the ln k there. Okay.